Pi does not exist. Hello everyone and welcome. Today we'll be talking about pi, the number related to a circle that we claim that we can get the perfect circle with it. We can get the area of a circle, circumference, and of course pi or the circle. This constant is used very widely in many fields. Okay, so in my opinion, I claim that this number cannot exist or can't be reached, and it is mathematically proven that it doesn't. We can't reach it. We can't reach the an actual rational number that can equal to pi. So I've watched recently an interesting podcast with Lex Friedman with a British scientist called Stephen Wolfram, and he explains how Boltzmann, German physicist who made famously the transport equation for the electron. We have many transport equations, but it's very elementary to understand the quantum physics. And he talks about how Boltzmann faced strong opposition when he tried to claim or make work based on discrete physics. And that the prevailing theory at that time is that physics or the universe is continuous. It's continuous. He made formations and made progress when he used discrete physics and got good results. But he said, as in the interview, openly say that the universe is discrete. So back to our concern, pi. To get pi, the number related to a circle in the first place, I think it does not exist. A perfect circle does not exist because it implies to have an infinite number of the dots at the circumference to get a perfect circle. So to get a circle, we have to prove first that infinity exists, which, in my opinion, it doesn't. It doesn't. Infinity maybe exists in our words. We can say that infinity, non-ending, but actually in the real world, can't find infinity, because if you find infinity, we can't have limits. We can't see things with defined parameters and volume. We can't have beginning and end, even present. Okay, this present moment will not even exist if infinity exists, which is a very topic on philosophy. And I think what Boltzmann faced was a pressure maybe related to philosophical, because if you said that infinity doesn't exist, it implies many things in philosophy and politics, consequently. I think that will be all. See you next time.
Boltzmann's time, he thought these molecules could be placed anywhere you want. He didn't think, but he said, oh, actually, we can make it a lot simpler by having the molecules be discrete. Well, actually, he didn't know molecules existed, right? In his time, 1860s and so on, the idea that matter might be made of discrete stuff had been floated ever since ancient Greek times, but it had been a long time debate about, is matter discrete? Is it continuous? At the moment, at that time, people mostly thought that matter was continuous. And it was all confused with this question about what heat is, and people thought heat was this fluid, and it was a big muddle. And but Boltzmann said, let's assume there are discrete molecules. Let's even assume they have discrete energy levels. Let's say everything is discrete. Then we can do sort of combinatorial mathematics and work out how many configurations of these things there would be in the box. And we can compute this entropy quantity. But he said, but of course, it's just a fiction that these things are discrete. So he said, Boltzmann had worked out how things could be discrete and had basically invented something like quantum theory in the 1860s. And but he just thought it wasn't really the way it worked. And then just to piece of physics history because I think it's kind of interesting. In 1900, this guy called Max Planck, who'd been a long-time thermodynamics person, everybody was trying to prove the second law of thermodynamics, including Max Planck. And Max Planck believed that radiation, like electromagnetic radiation, somehow the interaction of that with matter was going to prove the second law of thermodynamics. But he had these experiments that people had done on black body radiation, and there were these curves, and you couldn't fit the curves based on his idea for how radiation interacted with matter. Those curves, you couldn't figure out how to fit those curves. Except he noticed that if he just did what Boltzmann had done and assumed that electromagnetic radiation was discrete, he could fit the curves. He said, but, this is just it just happens to work this way. Then Einstein came along and said, well, by the way, the electromagnetic field might actually be discrete. It might be made of photons. And then that explains how this all works. And that was, in 1905, that was how that piece of quantum mechanics got started. But Boltzmann didn't think, Boltzmann kind of died believing, he said, he has a quote actually, in the end, things are going to turn out to be discrete, and I'm going to write down what I have to say about this because, eventually this stuff will be rediscovered, and I want to leave, what I can about how things are going to be discrete. But, I think he has some quote about how, one person can't stand against the tide of history in saying that, matter is discrete.
So he stuck by his guns in terms of matter is discrete.
Yes, he did. And the what's interesting about this is at the time, everybody, including Einstein, kind of assumed that space was probably going to end up being discrete too. But that didn't work out technically because it wasn't consistent with relativity theory. It didn't seem to be. And so then in the history of physics, even though people had determined that matter was discrete, electromagnetic field was discrete, space was a holdout of not being discrete. And in fact, Einstein, 1916, has this nice letter he wrote where he says, in the end, it will turn out space is discrete, but we don't have the mathematical tools necessary to figure out how that works yet.